without further ado, who do we have next? Eric, you want to intro?
Joseph, and I am not going to ruin your last name, so I'll let you say it, but he's just going to come talk to us about security as code, DevSecOps approach. Joseph's with GitHub Security Labs, runs this YouTube series called Security Bytes, along with a bunch of other stuff that I'll let him go over.
All right. Hey, and welcome to my presentation. This is Joseph from the GitHub Security Lab. Today, we are going to see how we can do security as code via a new DevSecOps approach. A bit about me is that I'm doing this job actually from my early teenage years because it was my own way to provide dedicated and ethical service to the society, organizations as a whole. So through the years, I started as a script kiddie, and then I've done cybersecurity in the military, then in university where I found a zero-day vulnerability for a top 10 cryptocurrency. I've worked a bit as a consultant, and now I'm focusing and I made the mission of my career to secure the open source software that we all depend on. Some of the ways that I've done this lately include Security Bytes, which is a YouTube series I have, in which I try to show software developers some common patterns and some mistakes they are doing often so that they can avoid them and we are all together living in a more secure place. The reason I do this is because I've noticed that YouTube is full of security people trying to show how you can benefit and exploit a vulnerability. But I was trying to show the other way around. So I hope you can have a look and maybe learn something new. I'm part of a team where we try to secure the world's software together. The way we do it is through 2 or 3 ways. By first of all, creating content like the one I've shown you. And we are also doing security research. In the past 26 months, we found 331 CVs, and the list is growing. And we publish this in form of advisories so that open source maintainers can see them, update the libraries, and these libraries are not part of a supply chain attack, etc. Today, I want to introduce security as code via an example from a company that I bet more or less everybody knows, which is NASA. And this is not like a Netflix scenario. This is a true story starting 10 years ago when NASA sent for the very first time a rover in the surface of Mars in order to start exploring the surface of this planet. And someone in the team of NASA, in the same way that some of your friends maybe in the car 20 minutes after you left home are like, oh, did we turn off the heater? Did we close the doors well? Someone in the team had similar questions. They asked, did we check for one last time the code that is responsible to open the parachute just before the rover gets into the surface of Mars? They checked the code that was similar to this one on screen, and they noticed that while in line 1, an array of 12 elements is being expected, you have one array of 3 elements being created and passed to this function, which can lead to random memory being accessed in line 2, because from the coordinates 4 onwards until 12, you can have random behavior, which could lead in the rover being crashing. The smart thing that the NASA engineers did was that they didn't just fix that specific vulnerable instance that we have in front of us, but they wrote a generic query in the language I'm going to demo today, which is called CodeQL language, code query language, CodeQL, to find instances, i.e. variants of this vulnerability in the rest of their code base. They realized that if we have this problem here, we might have it in the rest of our code. And they found 30 other similar bugs falling under this specific pattern that they could lead to the surface of Mars having a rover crashing into it. A year ago, they sent another rover. This time was called a mission. This time was called Ingenuity. But this time they have done differently so many things. They have shifted security left by integrating CodeQL in their pipelines from the very beginning. So they could pick problems like the one I've shown you very early in the process. In the same way that NASA secured their code, you can secure your code as well, because these queries that NASA people have written all these years are part of our knowledge and code base that we provide to you in order to secure your code. And my team with the 331 vulnerabilities is also contributing queries in that database, and people from the community where we can pay them bounties. But today, I'm not just here to show you how you can turn like a button on and have this functionality for your code base. I'm here today to show you how you can tailor these queries that are written from NASA, my team, the community, in order to be bespoke for your code base and benefit even more towards a culture of DevSecOps. So this methodology, we call it security as code. And we have been inspired about it from DevOps and quality assurance. The lessons that we've learned was that developers had in their hands the infrastructure. They didn't need to open tickets to infrastructure teams and operations teams in order to get something done. And from the moment they had this in an executable form under their control, DevOps has flourished. In the same way as quality assurance, instead of going and coming back to a team working in silos that is responsible for testing or the quality of code, you can have automation and make sure that with agility, you tackle these problems. So methodologies of the past, we don't believe that they will resonate more with today's software development. And by this methodology, we expect the security experts of an organization to codify their security knowledge in an executable, readable form so that developers and the rest of the organization can read, understand, change it, and in general, be all aligned in the same code is law way of doing things. We call this security as code, and the way I want to show you today how you can like execute it is by showing you CodeQL. CodeQL is a new language that stands for Code Query Language that is able to query data, to query code as if it was data, meaning that with CodeQL, you describe what you want to find and not how to find it. It's more like, give me all the people in this room, and from all these people in this room, I want to have that one with the gray GitHub shirt, which is the intruder or the person who is gonna attack us. It's going like that. So this means that it's declarative because you describe what you want to find, but it's also logical in the sense that you can use logical operators like and or to define relationships so you can be more specific and reduce false positives. That is a very pressing issue for modern security teams. What else about CodeQL? CodeQL right now supports JavaScript, Java, C, C++, C#, Go, Python, and we expect to have Kotlin, Ruby coming up very soon. The way that it works behind the scenes is by transforming your code into an abstract syntax tree so that it creates a relational database that can be queried in a way that is very flexible for you. And to add on flexibility, CodeQL is an object-oriented language, which is a bit strange because it looks like SQL in the demo that we are going to see together. But think about all those amazing features that you can get with object-oriented languages like code encapsulation, inheritance composition, and in general, by using types and stuff like that, you have way more power and flexibility in your hands. CodeQL is free for open source, and you can definitely turn it on by like spending 3 clicks in your public projects. When it comes to enterprises, there's a license that you can click on the specific button, contact sales team. You can find more about it. But like I said, today it's not about evangelizing CodeQL and turning it on your code. It's more about showing you how you can tailor, how you can write this language so you can benefit in situation where it's way more tailored to your needs towards a culture of DevSecOps. In our demo today, I'm going to show you how you can use CodeQL to find an SQL injection vulnerability that, as per our meme on screen, that is from XKCD. It's happening when unsanitized user input gets into the code base. For example, here we have a student's database that is expecting a student's name. The developer naively just uses a placeholder defined by 2 quotes, but in reality, someone malicious can close the quote and can use a semicolon to pass another instruction that is then being executed. In here, it's drop table students, but in reality, it can be adding more students in the database or adding someone who is of malicious intent as an admin. The possibilities are endless, but what is important is to see how we can pick this vulnerability using our SAST tool to write secure code. Just before going to the demo, I want to introduce some definitions so that you understand exactly what I'm doing. First of all, sources. Sources are places in the program where untrusted user input is being entered in the program. It's the source of the vulnerability. In our example, this could be insert into student's name, values, and the name. So that's the source. That's where unsanitized user input can get in. But a source is actually useless without a sink. A sink is the place in the program where that unsanitized user input is actually being executed. If you don't have an execution, i.e., if you don't have a sink, you have an unexploitable vulnerability. So the reason I show you this is because I'm striving as a security professional to reduce false positives, and I want to make sure that in our demo, we only pick those vulnerabilities that are actually exploitable, where the unsanitized user input is actually going through execution. Contextually, this is the place in the program in terms of sink where the SQL query is being executed. That's where it's the untrusted user input is being executed. So you have a vulnerability when you have data flow from a source to a sink. And let's now see CodeQL in action. So going to my code here, where I'm using VS Code, I have installed the CodeQL extension here that you can use your extensions here. You can write CodeQL, and there's the verified and official extension from GitHub. The code base I'm using, it's the intentionally vulnerable code base by OWASP. It's called Security Shepherd and tries to mimic an Android application. So think about any app in your phone where you click and it's asking you for a username and a password to log in. Here, my intention is to attack or basically to secure the authentication element of it. So I'm looking for SQL injection vulnerabilities in the app and specifically the authentication aspect of it. So my goal is to use CodeQL to describe how the source of the vulnerability looks. Then I'm going to describe how the sink of the vulnerability looks. And then I'm going to pass the source and the sink into a data flow template that was given to me like ready-made with 2 placeholders, a source and a sink, so that we can come up with confirmed SQL injection findings. So bear with me, and in less than 5 minutes, you'll see the true and real power of the tool, how it can show you all paths and all relationships with sources and sinks so that you can follow malicious code in your own code base. Let's start by showing you the source so that we can describe it. First of all, the code base is expecting a username and a password. Here you have a method that is called getText. That is specifically the method that we need to describe to find out those places in the code that receive untrusted user input. let me show you how we can write together some CodeQL. That's an empty file in where I can import the Java standard library in order for me to benefit from functions that have been already said and being polished for Java, so I'm more productive. And then, similar to SQL, I can use a from, where, and select clause to describe what I want to find. So I want to find those methods that are being accessed in the program. And let me show you how I can do this. I'm using a variable, sorry, I'm using a type that is being called method access. This type is able to return to me all the method accesses in a program. And then I'm using a variable that is called call, or you can call this variable like anything, like for example, C. It's not the same as, it's not the same as the type that needs to be specific. So that by using this variable, I can pass it into the select clause and get back every single method being accessed in the code base. That's not so useful though, because I'm not interested in all the methods in the program. I'm interested in just those methods that receive untrusted user input. That, as we've seen, it's the method getText. So I have to describe to this query by using CodeQL how a call to get text is looking like. So to restrict the input, I can use the where clause and say that I have a method that has a name. So I'm using like the autocomplete functionality, and look how the ID is helping me here, expecting a package, expecting a type, and the method name. So in plain English, here we say that there exists a method call here that when this method call is under the package Android.widget, because you have an Android app, the generic type is edit text. Think about every lion is an animal. So it's like every call to get text method is falling under the category edit text. So in reality, I can have here the keyword any, saying something like, oh, anytime there's a type edit text, I want to know about it because it means that unsanitized user input is getting into the code base. But I want to be more specific and find instances of getText. If I run this, I expect CodeQL to give me back those calls to the getText method that I know that they are sources of problems. We came up with 3 calls into that method. We don't know yet if all of these are vulnerable, if one of them is vulnerable. We need to find out. And that's where the magic happens, to find out which of those are problematic so that you spend your time more efficiently. Now it's time to find sinks of vulnerabilities. So the sink in our example is where the query is actually being executed, which happens in here when the raw query method is being called, but specifically when the first argument of this method is being set. Otherwise, if we just look for the raw query method, it's a false positive. We specifically want to have those occasions where the query or the first argument is being passed. First of all, I'm going to use the same methodology as before. And if we visualize this a bit, in the beginning, we wanted to find getText. We started from all the methods in the program, and we just filtered the getText. Now we want to find in the raw query method the first argument. So the methodology I'm going to follow is to get, again, all the methods in the program. I'm going to use the where clause to find just those instances that are calling the raw query. But I will further restrict that by getting those raw query methods that are having the first argument being set. And the way I can do that is by using the AND operator. So the first part of the where clause is similar to what I've shown you before. It's using the get method, has qualified name way, different package name here, different type, different method, but we want to restrict further. So I'm going to use the end operator and say that I'm only interested in those raw query calls that the first argument is being called. Well, I've shown you the method access here so far. And this method access was a type that could give me back all the methods being accessed in a program. Because I now want to find arguments, and arguments are of type expression, I'm going to use the expression type to get access to the first argument of the raw query method, and in reality, any other argument. So I introduced a new type here and a new variable. So if I further use this variable to restrict my input, I'm going to say that I'm interested in those raw query methods where the argument in index 0 is being set. So what you say here is, give me those calls to this specific method where the argument I'm interested at is the first one in the index 0. If we run this, we expect to come up with those calls to raw query that the first argument is being set. So far, you just saw something similar to a command find or a grep functionality, but the real power of the language stems from here. This is, if I zoom out a bit, this is a template. I didn't write this code. This code was given to me. I don't know if someone from the NASA team wrote the code or someone from my team, someone from the community. Because we work as a community, we work as a collective knowledge in which you can build by tailoring your query even further, in the same way I was writing code before. So in here, at the top, you have some metadata that are going to help us, but ignore them just for the results at the end. We imported some new libraries here to help us with the visualization we are going to see in a moment. And here I want to show you the object-oriented nature of the language in a bit more detail. You have a class that extends a superclass. You have a constructor here so that you can see how easy it is to reuse functionality. In line 14, we have a predicate, which is essentially a function, i.e. reusable portion of logic that is being overridden in the template, where we can pass the code we wrote here for the source, and in here we can pass the code we wrote for sinks. And that's pretty much it, because the language is then going to handle the question, is there flow between sources and sinks? If there is, we know we have confirmed SQL injection findings. To do this, I can copy and paste my code from before in here. And I want to show you another operator, which is called exists, which can make my code way more reliable. I can say that the source of the vulnerability is where there exists a method access. Let's name it C, such that this method access has some specific properties. Specifically is when it's a get text. Because we have flow from like one node to another node, the way it's represented is through nodes. So you have a node, which is an expression, and it goes to another node, like in an abstract syntax tree. And that's why you have a node type here. And I want to assign this source of vulnerability to a node. And to do that, I can use the end operator and say where node as expression equals this call to the get method access. And in here, we can use the same code as before for the sync. We can say that there exists a method access call. Let's use another variable name, such that it fits some other properties that we can take from here, specifically when this method is raw query and the first argument is being set. And because, again, we have nodes, we are going to say that I want to assign to my sink to be a node that is the destination node, essentially. So if we run this, we expect to come up with the true power of the language, which is confirmed SQL injection findings. And indeed, if we see on the right-hand side, we have 2 confirmed SQL injection findings that we can click the drop-down button and analyze together. So first of all, let's see the paths. We have 2 paths for the first vulnerability. If I click here, the source of the vulnerability starts to be the getText method, specifically for the username variable, that then goes to the login method. So the login method is getting a username and a password to check if they are indeed in the database by being evaluated to true. And then if we continue, we see that we are going now to the login method's signature, where it expects a username and a password. And finally, a query is being created and being passed into here, which is the sink. So that's the first path to the vulnerability for the variable username. Let's see if there's another path to the same vulnerability, again, for the username variable, as we see here, but through a different pathway. So if I click on the check name here, we can see that we are still in username, but I want you to see the difference between the lines 102 and lines 116. So we essentially have the username function, the username variable being passed into the login function. At first is being equaled by true, then is false. It's essentially checking if this user is part of the database. But in reality, what happens is that you can have an SQL injection vulnerability hitting your code, extracting sensitive data like addresses, credit card numbers, etc., without even being part of the database. Because indeed, CodeQL just told us that the vulnerability is also passing through lines 116 in the same way that it's passing through lines 102. If we continue to chase the vulnerability, we can see that it goes again to the login method, that goes again into the raw query that is being executed. And that's not everything, because we have another SQL injection confirmed finding by SQL, again through different paths. This time is for the password variable that is following the same pathway as the username, being checked for being true. In here is going to be checked if it's being false. Again, going to the login method, and finally ending up into the invocations of the raw query method, specifically the first argument. So someone could say that, okay, Joseph, I mean, how difficult was that for such a small code base? That's exactly the point. The point is that that's a small code base, and you had all the pathways to vulnerabilities. Imagine a real big enterprise or open source project code base, where you are going to have like dozens of areas in the program that the variable is passing by until it's being exploded. So to me, this shows that your ability to follow a taint in your code is really powerful, because it can show you exactly all paths to vulnerabilities, and you don't fix like 10% of it or 50% of it. Because in my time as a consultant and as a hacker, I've seen companies trying to fix vulnerabilities, and almost never they fix everywhere. It's very important to have a tool that shows you every path. And because a SaaS tool, even if something is not exploitable at the day, you can always tailor it by adding a bit of code in the same way as I did and make it more accurate. So if I go back to the slides, just to finish it up, you can start your CodeQL journey. That's the useful links I found myself, because I started my CodeQL journey not long ago, to be honest, like 6 months ago. What I found really useful was the fact that I could use templates and getting more productive very easily, in the same way we've used the data flow template together. And finally, I want to show an initiative from my team, which the open source community has really, really embraced, and we are very happy about it. We are offering our time for free to open source projects. So open source maintainers can come in contact with us about discussing the security surface of their project. They can discuss something security-wise that bothers them, and often often open source maintainers don't know what they don't know. We can help. So if you follow us on Twitter at GH Security Lab, which means GitHub Security Lab, you can find out when we open some slots and come in contact with us to help you secure your project. I would like to thank DevSecOps 24 today for having me. And you can find me for further questions at JKCSO in LinkedIn or Twitter. And you can also follow my team to see our latest advisories and our latest educational content that we provide to the community alongside our newly created initiative for community office hours. Thank you so much. And it has been such an honor and pleasure to present in this conference. Have a good one.
Awesome stuff, Joseph. Thank you. Thank you so much
Amazing.
for that. And I really do. I love that story about the NASA part of things and in there. So far, no questions in the chat right now, but I have one question for you that I find to be potentially interesting is in that sense of when people are being more active in writing the CodeQL code themselves, do you find potentially, or have you found folks potentially using GitHub Copilot to help them with that just yet? That other tool?
That's amazing. That's a great question. So I need to tell you an insight about that. So like 2 weeks ago, I was trying to get some, let's say, internal permission to speak exactly about that because it's coming.
Okay.
So I don't know.
All right, well then let's pause there. Let's pause there because we also need to start wrapping up too.
Okay.
But maybe I'll ping you offline.
I just want to say that we are testing Copilot now to provide security suggestions so that you can fix code with less. Let's keep it here. That was a great question.
Cool. Well, thank you again so much, Joseph. Glad we were able to get through all those internet issues and appreciate you being here. Have a good one.
Thank you too. Have a good one.